Welcome to The Explainer. So today, we're going to tackle a really weird paradox. How can you be completely surrounded by water and still die of thirst? We're going to get into everything from low-tech survival tricks to the massive global industry that's turning our oceans into drinkable water.
You know, it's one of nature's cruelest jokes, right? You're adrift at sea or stranded on a beach, surrounded by an endless ocean of water, but you might as well be in the middle of the Sahara. Taking a drink won't save you. In fact, it's going to make things worse and fast. So what is the deal with that?
Okay, so let's get right into the science behind the saltwater paradox. It really all boils down to a fundamental mismatch between the water in the ocean and the water in our bodies.
And here's the core of it, right here. Ocean water is about 3.5% salt. Our blood, it's way down at about 0.9%. That is a huge difference. Our bodies are these incredibly fine-tuned machines, and they just cannot handle that kind of salt overload. It basically sends our whole internal system into a panic.
So what happens is you get stuck in this terrible, deadly loop. Your kidneys, they go into overdrive trying to filter out all that extra salt. But to do that, they have to pull fresh water from your body's cells. This means you end up losing more water than you actually drank. The result? You get even more dehydrated, even thirstier. It's a vicious cycle.
Okay, so if you're stranded and drinking the ocean is off the table, are you just out of luck? Well, not necessarily. Turns out, with a little bit of ingenuity and maybe some plastic trash that's washed ashore, you can actually use the power of the sun to do the separating for you.
This is the classic survival technique, the solar still. The sun beats down, heating the salt water you poured in the pit. The pure water evaporates, leaving the heavy salt behind. That water vapor then hits the cooler plastic wrap and condenses back into liquid. And that little rock you placed in the middle, that's the genius part. It creates a low point so all those fresh, clean water droplets drip right down into your cup. It's slow, for sure, but hey, when you're fighting to survive, every single drop counts.
And here's another really clever method that works on the exact same principle. You're using evaporation and condensation. The salt water in that smaller container inside heats up, the fresh water evaporates, and it condenses on the inside of the big bottle. Then it just trickles down into that little collection lip you made. You're literally turning a piece of trash into a life-saving device.
Now, let's zoom out. What happens when we take this basic backyard survival hack and we scale it up? Way up. We've essentially taken that simple idea of separating salt from water and turned it into a massive global technology.
So take a look at this number, 45.5 billion. What on earth could that possibly be? It's not the amount of sand on a beach or stars in the sky, but it has everything to do with what we've been talking about. That is the number of liters of fresh water that desalination plants around the world produce every single day. We're talking about more than 13,000 of these industrial giants, all churning out fresh drinking water from the sea. They are basically giant, super efficient versions of that plastic bottle still we just saw.
So how do they do it? Well, most modern plants use this incredible process called reverse osmosis. After a ton of pre-filtering, massive pumps force seawater at insane pressures against a special membrane. Now, the pores in this membrane are unbelievably small, about 1,000 times smaller than a single human hair. They're so tiny that water molecules can just squeeze through, but the bigger salt molecules, they get left behind. And as a final step, they actually add some essential minerals back in so the water tastes right and doesn't corrode the pipes on the way to your faucet.
This all sounds amazing, right? Like the perfect solution to all our water scarcity problems. But you knew there had to be a catch, didn't you? Creating fresh water on this scale, well, it comes with some pretty significant hidden costs.
And the biggest one is energy. It takes a staggering amount of power to physically separate salt from water. We're talking up to 10 times more energy than it takes to treat fresh water from a river or a lake. A big desalination plant might need its very own dedicated power station just to keep the lights on, and that of course means a massive carbon footprint. And then there's this question. What happens to all the salt you take out? It doesn't just disappear, it gets concentrated into this waste product called brine. And get this, for every 1 liter of fresh water you produce, you're left with about 1 liter of this super salty, pretty nasty byproduct.
So what do you do with it? Well, dealing with that brine is a huge problem. Pumping it straight back into the ocean can create these underwater dead zones that are way too salty for most marine life to handle. Combine that with the huge carbon footprint from the energy use, plus the crazy high financial cost of building and running these plants, and suddenly desalination doesn't look like such a perfect silver bullet anymore.
Which really leaves us with this big, critical question for our future.
As our planet's need for fresh water continues to grow, turning the ocean into a faucet is going to look more and more appealing. But the real challenge will be finding ways to do it without wrecking the environment. So, is this the ultimate answer for a thirsty world, or are we just trading one problem for another?